Hello, everyone, and welcome to SuzaCon 23. Today, in this session, we are going to present on the topic of creating resilient multi-cluster architecture using Kubernetes and Service Mesh Istio. And the presenters for today would be myself, Tapas Nandi. I'm a pre-sales consultant at Suza, based out of Mumbai, India. And along with me, I have my colleague Deepak. Deepak, why don't you go ahead and introduce yourself?
Hey, thank you, Tapas. Good morning, good afternoon, good evening, depending on the part of the world you are. My name is Deepak. I'm a pre sales consultant at SUSE. I am based out of Bangalore, India. Back to you, Tapas.
Great, Deepak. So, in today's agenda, we would be covering the market trend, challenges, and solution. We will also see various issue deployment models, followed by a short demonstration. So, Deepak, in today's world, we know that businesses are driving towards digital transformation for a lot of good reasons. So, in all your conversations with customers, what do you feel is a major concern in this type of approach, and which all aspects leads to the maximum revenue loss?
Sure. So, it is aptly said, right? Measure what matters, right? So, organizations, right, would like to measure only what is actually most critical for them. Now, in the recent survey, right, across multiple organizations, right, uh, the following came out as a clear distinctive trend as to organizations who are really looking for number one in terms of securing their infrastructure, number two where their availability of their services were at the second topmost priority at 51%, followed by 43%, in terms of performances, right? So, when we look at the availability, right, availability stands out very clearly and it's very important. Now, if you look at the converse side of it, right, when there is an outage, right, organizations, of course, it outages leads to financial losses, right? But it also leads to brand image loss as well, right? So in the survey, they also found out, across industries and verticals, what was the impact of the outage, what was the financial impact of the outages. And it seems like energy industries, right, were the major hits with about $2.5 million an hour loss, followed by telecommunication about 2 million, and followed by retail about 1.1 million. That is a huge amount of money, and that's why the emphasis of measuring the availability is at the top of the charts, right? Now, organizations have also realized that when the availability is always there, right, when they are able to deliver their services to their customers, right, it has a very positive impact on their bottom line. It also improves the employee productivity for that particular organization, and it also gives that particular organization and competitive edge, of its competitions, right? So availability really stands out, as one of the most measured stuff across the organization, if I have to say, or one of the most important, I would say.
Deepak, those are some really concerning numbers right there.
Mhm.
Would you be able to highlight on some of the challenges that you have come across, and how did you overcome these challenges? Any solution that helped you to overcome these? So, can you please shed some light on that?
Yeah, sure. So, with respect to our session, right? So we are focusing on Kubernetes, and Kubernetes by design, right, gives highly available microservices architecture, right? But is it everything? The answer is no, right? There's always an additional layer of toolings, right, that is required to even improve the availability that we have out of the box from Kubernetes, right? Now, why I'm saying this, there's a reason to it, right? So, when developers, right, they develop the microservices, right, they're fundamental and the most important thing that what they worry about is their code, right? Now, when they build applications, right, they don't want to build any additional toolings other than what their code is, which means that they will have the basic mandatory security pieces of code within their application, which is only required for that application and nothing more than that, right? They will have the necessary, they would not want to have bake in any additional codes which will help them to to determine whether there is an performance loss when the microservices are talking among each other, right? All these they don't want to really look at, right? They want something which is available out of the box, and it's definitely not within Kubernetes out of the box, right? There are additional toolings like Service Mesh, which gives capabilities where you don't have the developers don't have to worry about all this, and they will just be able to focus on their code, right? So Service Mesh is the tooling what we require in additional, which complements the Kubernetes architecture and even gives a higher degree of availability, right? So Service Mesh gives us the capabilities like traffic shaping. You can do canary deployments, right? You can also observe your application monitoring and the observabilities of your microservices running across your clusters, or across your clouds, right? And then it also brings in the additional layer of security, and this is all out of the box. Your developers do not have to worry about all this, right? They can rely on service mesh capabilities without changing their code, and that's exactly what they want, right? And that's why service mesh, its importance is growing day by day. And Istio happens to be one of the most popular service mesh that we are seeing in the industry today, because of its capability, what I just spoke about. And also, in addition to that, there are various deployment models which caters to the end customer's requirement, whereby they can design the mesh to meet their needs, rather than just to kind of use what is available, and they're left without a choice, right? So Istio give them the much necessary choices in terms of the design and architecture of what will fit their bill the most.
Right, Deepak. So when you say we have multiple deployment models in Istio, would you be able to shed some light on the various models we have? What the various options customers can choose?
Absolutely. So, Istio will, you can deploy Istio on a single cluster or across multiple clusters. You can deploy Istio in a single network, or you could do it across multiple networks. You could have a single control plane of Istio, versus you could have multiple control planes of Istio as well. And then finally, you can have a single service mesh, or you can have multiple service mesh as well. And these are the four typical scenarios that we see. And customers can make a choice among this, and there are pros and cons, and I'm not going to dig deep dive into these architectures, but I'm just going to say that it just adds up to the availability of your applications, right? So if you're putting Istio on a single cluster, right, what if the cluster fails, right? The applications will not respond, right? So if you do it across multiple across multiple clusters, then your availability improves. Just as how what we have seen, right? If you're having applications on a single network, what if a network failure is there, right? What happens to that, right? So in order to to have isolations, capability of isolations, capability of not having worrying about IP addresses overlappings, and etc. You could have Istio across multiple networks. And similarly, you will have Istio across a single control plane versus multiple control planes, just in case if your core control plane has any problem. When you operate Istio across multiple control planes, your communication will still work. And then similarly with single service mesh and across the service mesh. So one of the service mesh has a problem, your application is still being served through the other service meshes which is available, which is going to serve your business requirement. So in fine grain, right, you can have layered by layered availability improvements based on the design. So, Tapas, I kind of just ran through this at a very, very high level, 30,000 feet level. But, it would be really interesting if we showed people in action as to how this actually works. So, can we have that quick demo where you can show this in action? Thank you.
Definitely, Deepak. So let's proceed towards demonstration. But before that, let us understand the current landscape a bit. So for today's demonstration, we will use a single mesh with multiple primary cluster deployment model, and the architecture of which is right on the screen. So we have two single node Kubernetes clusters and one control server from which we will be firing the commands. And our testing applications would be a small hello world applications. We will, to give an idea of what we are going to do, we will first define the cluster networks. We will then deploy Istio version 1.18 on both the clusters. We'll set up the east-west gateway and expose the services. We will do endpoint discoveries using remote secrets. And then finally, we'll deploy the applications by creating namespace and enabling Istio injection, and then deploying the application and seeing the magic.
Oh, wow. I'm eagerly waiting for this. So let's get started. First.
Great, Deepak. So let me switch screens. Is my screen visible?
Yes, I see. I see.
Okay, so we have three servers over here. One is the control server from where we are going to fire the commands. So this server basically only have the kubectl tool and the kubeconfig file combined for both the servers, and we'll set the context, and we will be firing commands from this control server. Um, uh, Basically, easing us, giving us the flexibility of running it from a single server.
Mm.
Okay, then we have two more servers over here, 221 and 222. So these are basically the two Kubernetes clusters, which we will be putting in the mesh. Okay, so let's go ahead and check what is presently deployed in the Kubernetes cluster. So if we go ahead and do the kubectl get nodes, we'll see that we have 1.24.9 RKE2R2 deployed on /15 SP4 operating system, and our local network is 192.168.4 series. Let's go ahead and also check the pod network. Okay, so we can see that the pod network is 10.42.0 segment. Okay, let us also check similar things on the second cluster as well. So in this cluster as well, we can see that we have 1.24.9 RK2R2 deployed on SUSE Linux Enterprise Server 15SP4. Local network is 192.168.4 series, and let us also check the pod network. And we have 10.42.0 segment. Now, as Deepak rightly said, we have similar networks over here, but because we are using a different network model, we will not have any issues with the overlapping.
Yeah, so it's basically two different clusters. So it's kind of separated by the cluster. Yeah, demarcated
Right.
by the cluster. Yep.
So let us first set the context of the clusters. So the Istio class 1 and class 2 is already defined in the kubeconfig file. So we will export the variables as CTX cluster 1 and CTX cluster 2. So whenever we call in the variable, we are firing commands on that cluster, and that's it. Okay. So to start with, let us first start with defining the cluster networks. Okay. So as you can see, I just created a file, cluster1.yaml. The contents of the file is basically the mesh. We have defined the mesh ID, which is a unique identifier, and the cluster name, which is a Istio identifier of the cluster,
Mm.
and the network name, which is network one over here.
Right.
Okay, and the kind here is Istio operator, which is going to be used by the Istio deployment.
Got it.
Okay, so let's go ahead and deploy Istio on cluster one with the file that we have just created. Okay, as you can see, we have called in the variable CTS cluster one, which means we are deploying this or issuing this command right on cluster one.
Mm. And you are using the Istio command line utility.
Yeah, I'm using the istio-ctl command line tool, which is present in the server. Okay, before deploying this, let us go ahead and check in cluster one whether there is any component of Istio already installed. Okay, so if I do this, you will be able to see that there are certain components already installed, Metal LB, Cube System. However, there is nothing of Istio presently installed on these servers.
Yep.
So let's go ahead and install it. This asks me which profile I want to use. I'll select the default profile, which will install the Istio core, Istio-D, and the ingress gateways. Okay. So it'll take some time because it's a fresh deployment and it's going to fetch the pods, fetch the images from the net.
To save time, can we do this on the other clusters, or you want to wait?
I'll have to open up another putty, but it's not going to take much long.
Okay.
As we can see, it's already install. We can go ahead and check on the cluster one, the status of deployment. And as you can see, the Istio system deployment is going on.
Oh yeah, you're right. A container creating.
So by now it should be
Oh, it's
created.
done.
Let's just hit the command again, and we can see that Istio and everything is running. Okay,
Correct.
so let's go ahead and deploy the east-west gateways on cluster one. Okay, similarly, we are defining the mesh over here, which we have already defined in the step one. We are naming the cluster over here, which we have again defined in the step one, and then to network as well. And we are issuing the command on the cluster one. So this will pull in the gateway pod and deploy it on the cluster one. Now, if we go ahead and check, we should have an east-west gateway
Git.
also running.
Yep.
Okay. Now, if we go ahead and check the services, we should be able to see these services have fetched an IP address of the local network, which has been provided by the Metal LB load balancer that we are running.
That's right.
Right.
And this is exposed to the external world. Okay.
Right. So this is the IP from which the communication will actually happen. Okay. So let's go ahead and expose the services now. Again, we are deploying it on cluster one and the cross network gateway created. Okay. So we'll be going to do the same thing on cluster 2 as well. So let us define the network of cluster 2. Over here, as you can see, the mesh ID remains the same because we have one single mesh.
Nice.
The cluster name is cluster 2 and the network name is network 2. So this is an Istio identifier, and as we are running a multi-network architecture, we have defined it as network 2.
Correct.
If it was a single network architecture, we would have defined it as network
Network
1
one.
as well. So because we are in one single network.
One single one.
Okay, so the file is created. Let us go ahead and deploy it on cluster 2.
So Istio is creating another abstraction of network on the actual Kubernetes network, so that that traffic is completely separated, within the Kubernetes. Perfect.
Right. Okay.
That is going to be used by the Istio envoys, envoy container pods, which would be a side.
Right.
Okay.
Okay. So let's go ahead and check the deployments in this cluster. And as you can see, Istio daemon container is been created. So now Istio ingress gateway is being created. Istio D is running, and now we can see that everything is running and our command is completed. Okay, let's similar to the network one, cluster one. Let us go ahead and deploy the east-west gateway on cluster two. Okay, the gateway is deployed. Let us expose the services. That's it. So let's go ahead and check similar things on cluster 2 as well. So we have east-west gateways, we have ingress gateways, and we have the Istio daemon running,
Istio daemon.
right? So let us check the services as well. As you can see, the east-west and the ingress gateway services have received local IPs from the Metal LB load balancer that we are running. Okay. Now let us do the endpoint discoveries. Okay, so in this step, we are going to create a remote secret on cluster one and push it to cluster two. That's pretty much it. Now this is the step wherein we are setting up communication between the clusters using remote secrets. Similar thing we will be doing on cluster two as well. So it's the exact opposite of which we did in the earlier step. We'll be creating the remote secret on cluster two, and we'll be pushing it to cluster one. That's it. So at this step, we are pretty much done with the Istio deployment and setting up the configurations. So going further, we'll deploy the application, create namespace, inject the namespace with Istio enablement, and we're going to deploy the applications. Let's first create the namespace on cluster 1. Namespace has been created. Let us create the namespace in cluster 2. The namespace which we will be using is the sample namespace. You can use any namespace when you are trying or when you are deploying. This is just for the demonstration purpose. Okay. Let us go ahead and inject the Istio enable variable inside the namespace. So as you can see, we have done it on both the clusters, and Istio injection has been enabled. So the namespace has been labeled. Okay. Let us go ahead and create the services. So as you can see, the Hello World service has been created inside the sample namespace. Let us go ahead and deploy a sleep pod. So the sleep pod is basically a pod which will be used for firing commands or calling the services from one cluster to another cluster. Okay. Now let us deploy the actual Hello World application on the sample namespace. Now, in this command, I would like to bring into your notice that the version which I have mentioned over here is v1. So this is just for identification purpose. In a real world scenario, the version would be similar. What we will be deploying in cluster one and cluster two. However, for the demonstration purpose, for identification purpose, I'm going to name the application differently, but the services that will be being called will be the same. Okay, so we have deployed the Hello World application v1 on cluster 1. Now in the cluster 2, we are naming it as v2 over here. Okay, even that is created. So our Istio setup is done. Our application deployment is done. Let's go ahead and check the deployments on both the clusters. As you can see, Hello World application is still getting installed. So we'll wait for a couple of seconds. We'll give it some time to get up. And once it is up, we will check the application resiliency. Okay, we have the Hello World v1 application on cluster 1 up. Okay, we'll wait, we'll give it some time more. Okay, we have the Hello World v2 application running on cluster 2 as well. Just take a note of the name. Over here it is named as v2, and over here in cluster 1 it is named as v1. Okay, let's check. So in this command, this we are executing this command on cluster 1. In the sample names, we have a sleep pod that we have just seen over here, the sleep pod. Um, we are executing this command from within the sleep pod and trying to call the service of hello world sample on the 5000 port. So let's see. There we go. So we are executing the command on cluster 1. However, we are getting a response from cluster 2.
Cluster.
And
Yeah.
we are receiving a response from cluster 1 as well. So this is how application resiliency works with Istio multi-cluster deployment.
Yes, this is basically what we're seeing is that the responses is coming from both the clusters and it's handled through the Istio, right? So yeah, this is the proof in the pudding, absolutely. So why don't we now,
Let's
simulate?
check from cluster 2 as well. I think we should just to prove it. So we will be getting response from cluster 2 as well as cluster 1.
Mm,
So as you can see, we have received response from cluster 1 and cluster 2 as well.
correct.
Okay, so as you just asked, we'll now scale down an application on V2 to 0, and we will replicate application down scenario.
Yeah,
So let's check. CTL, I think an example. Text. So we have one replica of Hello World V2 application running. So let us scale it down to 0.
that's simulating the downtime of
Application down
the
scenario, yeah.
yeah, or
Okay.
whatever.
So we'll use the kubectl scale deployment. Have replica is equals to 0. Have an n sample Hello World V2, the name of the deployment, and we mention the context aware. Okay. So now if we go and check the deployment, we have 0 application availability. Even if we check over here, we can see that Hello World V2 is terminating.
Yeah. So there's
Okay.
no V2 working on the cluster
Right.
2. So which is
Right.
V1.
Right.
So
So yeah,
no, go ahead, sorry.
what we will do is we'll go ahead and issue the command that we earlier executed. So we are trying to fetch the application from cluster 2, okay, and we'll see from where we get the response. There we go. We are still receiving the response from v1, which means our application is up. If we didn't have set an identifier, we wouldn't have come to know from where we are getting a response.
Absolutely.
My application would have been up all the time.
Yeah, and this basically is what we are trying to prove, right? So I mean, when
Right,
you're running the application across the clusters in the single mesh, even if one of the the application in one of the clusters is having a momentary issue, or some glitch, right? Then the services running on the operational cluster through Istio is going to get a response, and that would mean that there is no downtime at all, right? Consumers are not going to see that, right? It's just a momentary fraction, and then
right,
it feels,
right.
yeah, absolutely.
So let us scale up the application again.
Mm-hmm.
So let's scale the application to 1 as it was before.
Okay.
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 So we have it scaled. Now if we check, it is again one replica available.
Mm-hmm.
Go ahead and see Hello World V2 is running.
Yep.
Now if we again check it,
Yep.
it will start responding from both the clusters now. Again.
Yeah, V1
Okay,
and
there we go.
V2.
We
Yeah.
have responses from V2.
Excellent, excellent. Oh, this is fantastic, Tapas. I mean, brilliant demo, by the way. Yeah, I mean, I
Thank you,
love it.
Deepak. Thank you very much. So over to you, Deepak. Why don't you summarize now what we have done? Deepak, I'm not able to hear you.
Oh, my bad. Sorry, sorry, muted myself. My apologies.
Oh,
Right,
it's okay. It's
apologies.
okay.
Can you switch to the presentation if you don't mind?
Sure, sure.
Yeah. So what today we have covered is the trends, the challenges as well as the solution. Tapas, I don't think the screen is. Thank you. Uh, you could go back. Yes.
Yeah.
So we covered the trends. We covered the challenges. We also found a solution for our challenge. Right. We went through the Istio. What are the benefits? Why Istio? Right. We also went through the options available under the deployment model of Istio, and we saw one of that option live in action. Thank you, Tapas. You did a great job there. So, just to summarize, right? Um, what we wanted to demonstrate today was that availability, although is by architecture in Kubernetes, applications are highly available, but Istio just adds up to that and improves the availability and also gives additional capabilities what we would need. So if you guys curious, right, to know more about the solutions from SUSE, we have used our own Kubernetes distribution RKE2 to demonstrate that. Thomas, can you go to the next slide, please? We have got some links basically for that for you guys to go through, and we also have the rancher learning community link, so you can definitely take advantage with all those trainings and learnings available on the community. So I do appreciate your time for today, Tapas. Thank you so much for taking us through the demo, and
Thanks, Deepak.
really appreciate everyone's time, and hope you had a insightful session. And if you need more, reach out to us. Yeah, thank you so much.
Thank
Bye
you.
for now.
Thank you.